It's time to start. Yep. All right. Good afternoon, everybody. It's once again time for a nice, warm, sunny afternoon of organic chemistry, Chem 170, with me, your host. If you notice when I do this, my eyes pop open. I don't know what it is. It does it again. But anyways, time for organic chemistry. All right. Couple important things. First of all, don't forget commercial from the management. Me, if you have any questions about anything dealing with this class, anything else, I don't know about some of the other stuff, I may not be able to help you. But with this Chem 170, come to my office hour tonight, starting at 6 on Zoom. You're always welcome. And remember, there's no such thing as a dumb question in my world ever. Now, let's go to wrong school. Let's go to D2L. If you notice, yesterday afternoon, let me check real quick. Thumbs up, people. You see Chem 170? Thank you. And I really appreciate everybody, because sometimes Zoom, you think you've got it on the screen where other participants can see it, and they don't. All right. On a week from today, Wednesday the 14th, the day before taxes are due, I'll be giving test number 3 online. It will be like test 1 and 2. I'll be sending you, you'll be having sometime Tuesday afternoon in the assignment area of D2L. I'll have the password protected PDF file for test number 3. You can download it. On Wednesday after our class, sometime maybe even a little earlier if we end earlier, I will send out an email with the password for that test. You have until Thursday, 1 p.m. to finish test number 3 and upload it to the assignment area D2L. Should take you about 40 minutes, but I say if you want to take up an hour and a half, I won't tell if you don't. If you want to take 2 hours, go right ahead. You know, it's one of those things, you either know it or you don't, which is why I don't get bent out of shape now that we're all doing it at home. All right, let's look at test number 3. It has 9 pages, 10 problems. Some of the problem are multiple part. In Chem 170, I've never used multiple choice. It'll cover carboxylic acids, esters, carboxylate anions, amines, amine salts, quaternary ammonium salts, amides, and heterocyclic compounds. Here's the point breakdown for test number 3. General knowledge, 7 points. Nomenclature, 38 points. Reactions, 60 points. Remember, nomenclature, there are 2 types of problems. That is, here's the molecule, give the IUPAC, or in this case, also common name, because in amines, I only taught you common names, and quaternary ammonium salts. Or here's the name, draw the structure. And it'll have reaction 60 points. I think I have 3 or 4 synthesis problems, which is give the starting materials for following reactions. And it adds up to 105. So there's 5, oh, I better, 5 extra credit. Which ones are? You pick them, because it just adds up to 105. And as with all tests, it's not open note or open anything on the internet or my videos. On Monday, this coming Monday, I'll do my world famous review for the next test, in this case, test number 3. I'll also go through the amines this coming Monday, because I've already finished it. The amines, quaternary ammonium salts, amine salts, and amides problem set on Monday. Make sure you try them over the weekend. And we'll have our regular Zoom meeting and lab and other material. And then afterward, I'll send you the email. On Wednesday night, don't forget I have my office hour next week, like I have tonight. And if you have any questions about the test, always feel free to ask. If we were face to face, if a student has a question, I answer it. I'm not going to give you the answers to the questions, but if you're confused about something, I'll help to try and unconfuse you, or as we say professionally, clarify it, whatever your question is, with a clarification answer. Ooh, Dr. White's using fancy language. Look out. And that's test number 3. Now, anybody have any questions about test number 3? I'm looking at the chat thing at the bottom, see if it lights up. Going once, twice. And if you want, after class, if you have a question, always feel free to ask or come to my office hours or email me. By the way, Wednesday afternoon and evening after class, and also part of Thursday morning, I'll be checking my email. So if you have any, about every 2 hours, if you have any questions, email me and I'll answer. All right. With that, let me just close something first. All right, now let's go through the practice problems for carboxylic acids, some carboxylate anions, and amine salts. All right. Oh, before I do this, I have to ask, did anybody happen to pick up a bottle of vinegar and think it contains acetic acid, which is a carboxylic acid? Anybody happen to pick up a bottle of ketchup or mustard and see it contains vinegar, which contains acetic acid, which is a carboxylic acid? Boy, I think I'm going to do an oy vey. That means, oh no. But did anybody happen to pick up a box or a bottle of fabric softener? Think about it, it contains a quaternary ammonium salt. Did you happen to go outside and smell the flowers and think that's esters you're smelling? Did you pick up a bottle of nail polish remover and think about it has ethyl acetate? Oh, I see someone got something they're showing me. What is it?
It's an orange.
Ah, did you happen to smell an orange? Can you smell the orange? And that's an ester too. Did you see anything like, oh, bananas or smell the banana? Do you think that had an ester in it? Oh, come on. I don't have much time. Our time's winding up. This semester really went boom. But remember, organic chemistry is all around you. I stole that from SpongeBob. And it won't hurt you to think about it outside the classroom, or in this case, it's a Zoom room. Is that a right terminology? I'll use that. I just invented a new word, a Zoom room. Say that 5 times, hold on. The Zoom room, say that 5 times quickly. Nah, you don't have to. Remember, think about organic chemistry in your everyday life. It's there. It's screaming at you. All right, let's do the problem set. Remember, I do 1 page at a time. If you have any questions, ask. All right, now, everybody see carboxylic acids and esters problem? Thank you, thumbs up, you really, thank you. All right, give the IUPAC name for the following. As you know, IUPAC means the official. Ooh, look for what's different. Carbonyl, carbon double bond oxygen with a hydroxy group and R group. So carboxylic acid, how do we name that? Find the longest chain with the carbonyl carbon, name it as an alkane. Butane, 4 carbons, drop the E and add the letters OIC and the word acid. Now, there's one exception, and that's this, where R is a benzene ring, and therefore IUPAC in their infinite wisdom said, well, we better use the common name and make it IUPAC, and this is benzoic acid. Now, when there's an alkyl group, let's look at E, the carbonyl carbon, just like in an aldehyde, is number 1. So how many carbons? 9. Nonane, nonanoic acid, drop the E, add OIC, add the word acid, and there's an isopropyl group on carbon 4 and an ethyl group on carbon 7. So this would be 7-ethyl 4-isopropyl nonanoic acid. Now, if you put the 4-isopropyl first, 7-ethyl second, I would allow you to do that, even though the IUPAC police would tell me, you're under arrest. There's no IUPAC police, but it sounds good. Now, what do we have here? Ooh, we've got a carboxylate anion. You do the same as an ester. The cation, your name is front, using the name of the element it comes from, Na, sodium. Then you name this, if it's not aromatic, you can use that way the student of mine in Chem 170 long ago invented. I always like to give credit where credit is due. And propane, 3 carbons with the carbonyl, drop the E, add OATE, and that's sodium propanoate. Now, with this one, when R is a benzene ring, you do have to use the IUPAC, still put the cation as the name of the element it comes from in front, but now this would be, if it was an H, benzoic acid, drop the IC in the word acid and add ATE, and this is potassium benzoate. Ooh, that reminds me. Anybody happen to pick up a can of pop? You know, my favorite, Dr. Pepper and Werner's, and look at the label, and does it say, Dr. Pepper, at the very end, Tom, does it say sodium benzoate? Is it there?
Yes.
See, Dr.
Yes.
White's not lying to you. Remember, sodium benzoate in pop is a preservative, and that's a carboxylate anion. Wow, that's some nice general knowledge you got.
And phosphoric acid.
But that's something else. That's inorganic. We don't talk about that stuff. All right, let's get back. And here we have an ester. How do you know that? Carbonyl, oxygen to the carbonyl, R group here, R prime, R group there. How do you name it? The R prime, the group on the alkyl group on the oxygen here, you name in front as an alkyl group, ethyl. Then you can either use longest chain, propane, drop the E and add OATE, or you can use carboxylate carboxylic acid name, drop IC in the word acid and add OATE. And either way, you get ethyl propanoate. Now, there's a couple of common names I've asked you to learn. Nobody ever calls this acetic acid. And here, draw the condensed structure for the following organic molecule names. Acetic acid is never called ethanoic because nobody calls it that. They call it the common name, ethanoic acid. Now, if we look at C, and this is a molecule that gave me a lot of grief years ago in my life, and I told that story, but you start from the right and move left. OIC acid, carboxylic acid, this were an E hexane, 6 carbons. The end carbon here has the carbonyl and hydroxyl group. Then on carbon 2 is an ethyl group. Now, if we look at F, OAT ending can either be an ester or carboxylate anion. If you see a name of an alkyl group in front, it's an ester. If it's a metal, then it's a carboxylate anion. In this case, alkyl group. If this were an E, propane, 3 carbons, carbonyl, oxygen, what's R prime? Ethyl. Oh, put a big X through G. I didn't take this out. I'm sorry. Remember, I promised, Dr. White keeps his promises, that I will never give you an ester or carboxylate anion with an R group on the chain. Yes, I can do it, but making your life just a little bit easier. Excuse me. And here is the other common name you should know. This is ethyl acetate. The IUPAC name is ethyl ethanoate. Nobody calls it that. Everybody calls it ethyl acetate. How do you get that acetate from? This would be if this were an H, acetic acid, drop the IC, add ATE, and you have ethyl acetate. Now here, this would be benzoic acid. It's a carboxylate anion. You have to use the IUPAC method. And there, the cation, one with a positive charge, the element name was sodium. OAT ending tells you it's from benzoic acid, and here it is. By the way, put an X through J. I'll never ask either magnesium or calcium. We talked about it, but I won't put that on the test. I'll stick to the alkali metals, sodium, lithium, and potassium. Now, problem number 3, and remember, stop me if you have a question, because Dr. White does questions, encourages questions. Remember, there's no such thing as a dumb question. All right, draw the condensed structure for the organic product or products for the following reaction. What do I have that's different? Carbonyl, hydrogen, carbon, aldehyde. O in a bracket means oxidizing agent, like potassium permanganate is one of them. And you replace the H with an OH, go from an aldehyde to carboxylic acid. The R group comes along for a ride, and that would be this reaction. 2 important things you should always remember for test 3. Test 3 is how many bonds to carbon. Doesn't that look like it's coming right at you? And do you break carbon-carbon single bonds? No. So remember those. That will be your friends always. And if you notice, D, I did the chemistry instructor's favorite trick on a test. Ooh, look, a big scary R group, big scary molecule. No. If you look at this carbonyl hydrogen R group, aldehyde oxidized, this H becomes an OH, and the R group that's big and scary, it's only big and scary if you don't know it's just coming along for a ride, came along for the ride. Now, this is a really cool reaction. Well, you know, Dr. White loves Grignard. What's different? Carbon with magnesium halide, Grignard. I don't have down here, but X can be chlorine, bromine, or iodine. And carbon dioxide is cool because you can do this with dry ice. And it reacts with second step acid and water to give a carboxylic acid that's 1 carbon longer than the R group we started with. 2 carbons here, we have 3, 1 carbon more. And here, like in 4A, what did I do? I gave a big scary R group, but carbon-carbon. Remember, let me remind you, when you're looking at an organic chemical structure, look always for what's different. what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond is where the action is. That's where the fun is, and that's where you should be focused. And here, carbon, hydrogen, carbon. Oh, magnesium halide on a carbon, Grignard. Carbon dioxide, second step, acid and water. You get a carboxylic acid that's one carbon greater than the R group you started with. Now, carboxylic acids are acids, and the acidic proton or hydrogen is on the oxygen, reacted with a base, you'll get the carboxylate anion. And this class M will either be sodium Na, potassium K, or lithium Li, and you get the carboxylate. You also make water, but that's an organic. Now, KOH will not react with a benzene ring, but it will react immediately with the H on the OH of a carboxylic acid to form this carboxylate anion. Now, there's one difference on this test, and that's question number 5. Normally, I ask this give the organic product or products, but number 5, and notice this underlined so you don't miss it. Make sure you read questions carefully always. Draw the condensed structure for all of the products of this problem. And here, what do we have? Ooh, carbonyl hydroxy group R, carboxylic acid. Ooh, NaHCO3, baking powder. And baking powder, remember, that makes the pH go higher. And what happens is acid-base neutralization. You get this carboxylate anion, but the baking powder, as I showed you in class, forms carbonic acid, which immediately breaks down carbon dioxide and water. The arrow here tells you CO2 is given off as a gas. And here I just changed the R group, and that's that. Everybody remember the little story I told you about the rocket ship with the most awful candy inside? You take it off, throw it away. You know, it was bad if a 5-year-old throws away candy. Oh, it was awful. But my father taught me how to put in baking powder and vinegar. Remember, vinegar has acetic acid, which is what we just did. And put the cap back on, hold it, and the thing would build up CO2 pressure and go boom, and you'd be shooting off a rocket. And if you were really good in your timing, it would go about 3-4 feet. And to a 5-year-old, let's see how tall was I, about that tall, it was cool. My friends thought it was cool too, even though back then nobody used the word cool yet. They loved it. So did I. All right. Question 6A and 6B, put an X through. I shouldn't have used calcium hydroxide. I should have used like lithium hydroxide or something like that. Just take it off. All right, let's look at the next couple. And what are they? Look for the functional group. And the functional group is a carboxylic acid to the first one. And what do we have here? Carbon hydroxy group alcohol. And acid catalyst, H plus is the acid catalyst. And carboxylic acid, alcohol, H plus, you form an ester. What's R? This group right here. What's R prime? The circle sort of got in the way of the prime or vice versa, but carbonyl, R group, 3 carbons, oxygen, R prime, 1 carbon. Remember, the carbon with the hydroxyl group is the carbon that the R prime will be attached to this R oxygen. And you can see that true here. Carboxylic acid, alcohol. R is benzene ring. Acid and an alcohol will not react with a benzene ring. This is the beauty of functional group chemistry. If you don't know where it reacts, guess what? It doesn't. In terms of organic chemists knowing it, anyways, alcohol, carboxylic acid, R is benzene, R prime is isopropyl. The carbon with the hydroxyl group, the middle one, is the carbon, the middle one, that's this oxygen, and you get isopropyl benzoate. And I've done next ones, this makes some very, very scary R groups. And here, what do we have? Ester, sodium hydroxide. I forgot to put the water there. Sorry, but I put it here. Ester, base, and water. You get the carboxylate anion of the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. Why not the carboxylic acid? Because in the presence of base, this forms immediately. And here's R prime. Remember, the carbon in R prime here with the oxygen will be the carbon in the alcohol with the hydroxyl group. Oh no, mistake. This should be K, not Na. Mistake. Oh, I'm going home. Wait, I am home. That should be a potassium plus, not a sodium. Now, if you take an ester and react it with now acid water, remember, we'll be coming back to this because this is the chemistry, how your stomach breaks down fats and oils you might have consumed. Like if you had butter on toast this morning, the fat in the butter, how did your body break it down? Ester, acid water, acid hydrolysis, and now you get the carboxylic acid you would have used to make that ester, plus the alcohol you would have used to make that ester. And here, carbonyl, what's attached to it, R, what's attached to this oxygen, R prime, get the carboxylic acid you would have used to make that ester. And the carbon in R prime with the oxygen is the carbon in the alcohol with the hydroxyl group. And the next couple, all I did was put some big, scary R and R prime. But if you know what you're looking for, it's straightforward because you use the general reaction. Example here, here's R, because I have an ester. Here's R prime, acid and water, R carbonyl OH, carboxylic acid I would have used to make that ester. And here, the ring will have a hydroxyl group phenol, and this is the alcohol you would have used to make that. Now here, I sometimes forget, I'll look and make sure on the test I don't, because at my level, you don't ever put the two there, but for you people, I will. What do we have? An ester, Grignard, seconds, not one, but two molecules of a Grignard, and second step, acid and water, and you get two alcohols. What's attached to the carbonyl carbon is still there, R. You lose this carbon that was the carbonyl carbon becomes an alcohol, and you make not one, but two carbon-carbon single bonds, and then this OR prime becomes this alcohol R prime OH. And if you notice here, this is R, here's R prime, my Grignard is R triple prime, carbonyl carbon, the benzene ring is still on that carbon, OH, and then I make my two carbon-carbon single bonds. And the carbon with the magnesium halide is the carbon bonded to the alcohol from the carbonyl carbon. And this one, you get the second alcohol. If you notice this one, I got really complex. Here's our ester, Grignard, second step. What's attached to this carbon with the hydroxyl group, ethyl, And then I'll have these two chains right here. This carbon has the Grignard, so that's the carbon bond to the carbon with the hydroxyl group. R prime, I get ethanol as my second alcohol. And any questions? Oh, I have a question.
Yeah, I need to go over F again.
In this one right here, F?
Yeah, 7F, yeah.
All right, let's take a look. You have an ester.
Right.
And you have two, I forgot two, like I said, but on test I will. Grignard. Second step, acid water. Now, the Grignard attacks the carbonyl carbon, both of them, and makes it an alcohol and kicks this part out as the alcohol. Let's go back up here. You see the, Tom, you see the general reaction?
Yeah.
Let's do something even make it easier for you. And this is one students have a problem with. Oh, I remembered it too. All right. Remember, keep your eye on the carbonyl carbon because that's where the fun is. I think I told you in my heart of hearts, somebody ever asked me, what kind of a chemist are you? I would immediately answer, I'm a carbonyl synthetic organic chemist. The carbonyl group is the best. But anyways, this carbonyl carbon, what's attached to that stays attached. Then it opens up to an alcohol. And the two are double, triple prime are bonded to that. Then this part here gets spit out. That's professional. And you get this alcohol. Okay. Now, unfortunately, I did go through it in the lecture, and you might want to go back to the videotape. But
Yeah, I will.
I showed you the mechanism, but unfortunately, we don't have time to go mechanisms because every reaction I show you this semester, yes, Dr. White knows the mechanism, partly because my research advisor, who I will forever be grateful, I was in his research group when I was getting my PhD and taught me to be an organic chemist. Beat into our heads. You should always know the mechanism because that way you can understand what you're doing. And I learned that lesson well. So here's the general reaction. All right, now, what's R? And this one I made harder than I would do on a test. Did I tell you that? I don't know if I ever. You guys ready for Dr. White's secret? I always put things in a problem set, some of them harder than anything I would ever put on a test, because that way, if you can do those hard ones, the ones on the test will be easy. And think about athletes who practice. They practice usually harder than the actual game environment, because if they can do it under those tough circumstances when they're doing whatever it is they're going to be doing, in terms of, say, basketball, hockey, or football, then they'll do it quite well. Well, I do the same thing in my practice problems. And so this is R, what's attached to carbonyl. This is R prime, and the Grignard is R triple prime. R cyclohexane ring CH2 is still attached to that carbon. this will become an alcohol. My Grignard, this are triple prime, two of them will be bonded to the carbon
Okay.
with the hydroxyl group. Then this other R prime will become this alcohol.
Okay.
And thank you for your question, because all questions are good questions. I truly mean that. I'm not just saying that to be, ooh, look at how Dr. White does. No, that's how I practice. Even if we weren't in a class setting, it would still be true. All right, let's go back to what I was going to do. Why don't you try this one? What would be the two starting materials you react with acid H plus to make that molecule? Since you might not have started studying, I mean, really knuckling down study. I'll help you out. How many of you want to put your answer up to your screen? If you don't want to, give me a thumbs up. All right, let's see it. Do it again, Justine. Thank you. Who do I pick on next time? The dean will be happy if she ever watches this. I've been trying. Sometimes Dr. White can be very trying. All right, it's Bad Humor Wednesday. All right, let's do this. What do we have here? What's different? Carbonyl with an oxygen. This is an ester. And how do you make an ester? Carboxylic acid, alcohol, acid catalyst. This is R prime. This is R. Therefore, my R, doesn't matter which order you write these in, but would be this with acetic acid. And then my R prime, ethyl. No, Dr. White just had a brain freeze. By the way, at my level, sometimes simple structures we don't even write down, and we use abbreviations I don't teach you in this class. But in my level, this is how you abbreviate an ethyl group or ethanol. And everybody you're talking to knows the structure. All right, let's do another one. What would you react with LiOH, lithium hydroxide, to make that compound? Anybody happen to look at a box of fabric softener or bottle? Think of quaternary ammonium salts? Something that's near and dear to my heart, and still is. Because you know, quaternary ammonium salts are one way to kill on a surface. Oh, I've got someone else willing. Hold on. Wait a second. All right, Tom, say something and hold up your piece of paper. You got to say something.
Organic chemistry is all around us.
And the answer, you missed it. That's why I don't like doing that either. But let me show you how to do the correct one. And guess what? That's why you're learning. You make mistakes and you learn from your mistakes. If anybody tells you they've never made a mistake in their life, they're lying to you. Trust me, I've made enough. And what do we have here? Let's do the general reaction. Ooh, a carboxylate anion. And this is MOH, where M for my class can be sodium, potassium, or in this case, lithium. And what do you react? A carboxylic acid. And what's my R group? Benzene. Therefore, if I take benzoic acid, I'm having a bad ring drawing day. You know, I have bad hair day. Yeah, I can have bad ring drawing days. Let's see if I can be a little more careful. That's better. And if you take this molecule, remember this is the acidic proton that would give you the product. Okay, do you see where you forgot the carbonyl and the oxygen? Yeah. And that's part of learning. Oh, let's do one more. Now, I will never give you a Grignard reaction where you have to do a synthesis, but I will ask you, to know how to do a reaction. So if I react those two together, what would be the product or products of the following reaction? 3 points each. Have some fun. Dr. White likes to share the fun, especially with a Grignard. It's a lot of fun. If you're done, give me a thumbs up. And for today, I'll give you a little help. All right, anybody need more time? Going once, twice? All right, let's do this. What do we have here that's different? Ooh, carbonyl with an oxygen, carbons here and carbons here. We have an ester. And I better ask, everybody see the whiteboard? Didn't know that was named after me. If you buy that, I can sell you a bridge in downtown Chicago cheap too. But anyways, what do we have here? Ooh, two of something. Carbon, 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 magnesium halide. And that's the Grignard. Remember here, X can be chlorine, bromine, or iodide. In this case, it's bromine. And what you get after a second step of acid and water, which we have here, you get two alcohols. First one, what's attached directly by a carbon-carbon bond to the carbonyl carbon is still attached. And then my two Grignards attached to that same carbon, you have an alcohol. Then the R prime from the ester is the other alcohol. So this is R prime, this is R triple prime. And therefore, what's attached to the carbonyl carbon, which becomes the carbon which has the hydroxyl group, this alcohol is still there. What's my R prime? Remember, the carbon with the magnesium halide is the carbon attached, in this case, the N carbon of 3, and you have two of those R triple prime. And one of the things I should have done with this problem, which I will do on a test, is put a plus sign. And then the other alcohol, R prime, is methyl. And that's how you do it. So you should be well versed in how to do this. There'll be a couple synthesis problems, I think 3 or 4. And just let me put in a plug. If you have a chance today or tomorrow or Saturday or Sunday or Friday, you have to go out and smell the flowers because they're starting to just come out now. If you can smell them, or better yet, go to a florist shop and smell the roses. Dr. White loves smelling roses. You're smelling esters. And I think we're going to take our break about 20 seconds early, unless, does anybody have a last minute question before we take our 5-minute break? And we'll come back, we'll do some lipids. We'll also do the lab, and I'll get you out early today, well before midnight.
Yeah. Can you just go to the whiteboard to the last problem again? I didn't get the last part of it. I'm writing slow today.
There you go.
Okay, that's R prime OH. Okay. Got it. Thank you.
Right. With that, let's take our break, come back at 1:55, and I'll see you in a couple minutes. I can go stretch. It's time to start again. Come back. I'm back. All right, let's get going again. And before we go any further, I think I should have you do something that's fun. So let's play that great game, circle and name the functional group, 2 points each. As soon as I get rid of this, There you go. That'll keep you busy for a while. I can go take a walk around the block while you're working on this. Remember, it's a fun game. Circle and name the functional group, 2 points each. Now, if you look at G, I think I threw everything in there but my kitchen sink. Nah, it wouldn't have fit in there. I'll be right back. I need a water bottle refill. All right, give me a thumbs up if you're done. See a couple people still working, so hang in there. Those of you finish early, think about the fun things in life, like breathing, organic chemistry. All right, I think everybody's done. Let's take a look at this. Let's play that fun game, circle and name the functional group. And let me just check real quick. Thumbs up, people. You see my whiteboard? Thank you. All right, look for what's different. What's not carbon, what's not hydrogen should get your attention. If we look here, oxygen there. What do we have? This part you don't have to do, but I will. What is that? A carboxylate anion. Yeah, I got to go to, I think I'm done for no. Carboxylic acid. And then we go to B. Ooh, sodium, that's different cation. Oxygen with a negative charge to carbon with double bond to oxygen, carbonyl, R group. And that's the carboxylate anion. And you could also call carboxylate salt. I like anion better. And then if we look at C, carbonyl oxygen. On this oxygen we have R, on the carbonyl R. Oh, by the way, you'd circle this. And what is this? It's an ester. And there you go. If we look at D, ooh, a nitrogen. Carbons here and here. What is this? It's an amine. Next, ooh, look at nitrogen here, oxygens here. This has two functional groups. What do we have when we have either 4 R groups on a nitrogen, has a charge, and you have a cation? And what is this? A quaternary ammonium salt. And over here we have a carboxylic acid. And now let's look at G. Oh wait, F is hiding underneath me. Carbonyl, nitrogen carbons, carbons under carbonyl. Remember, our prime and our double prime can be, can I write any smaller? I bet I could. Hydrogen. And this is an amide. And finally, G, nitrogen with our prime and our double prime, which they are hydrogen. Carbonyl, that's an amide. Ooh, nitrogen here hidden away. Carbons there and there. That's an amine. And I didn't have room up above, but I can do it now. An amine. Here's the general structure of different types of amines. Over here, we have an ester. And over here, we have a quaternary ammonium salt. And that's how you play that fun game, circle and name the functional group, 2 points each. I hope you all had a good time playing it. Seriously, if you can't name a functional group in a molecule, identify it, how are you going to know how to name it? How are you going to know how to react it? You don't. And that's why it's important to know how to play that fun game, circle and name the functional group, 2 points each. All right, let's go back to when I started on Monday, lipids and detergents. A lipid, everybody see that on the screen? Thank you. Thank you, Martin. Thank you, Justine. I'm so grateful everybody helps me out. All right. Remember, a lipid is, I'll never ask this on a test, but a lipid is something that comes from a plant or animal, chemical, organic chemical, that's solid, not soluble in water, but soluble in non-polar things. I'll teach you later on, like ether, hexane, gasoline. Don't try this at home. All right, now switches on. And there are two types of lipids. One is called saponifiable. The other is called non-saponifiable. And a saponifiable lipid is a lipid that can be hydrolyzed under alkaline conditions to yield carboxylate anions, which specifically the salts or carboxylate anions of fatty acids. But you don't know what a fatty acid is yet. Another way of saying this, base hydrolysis of a saponifiable lipid gives carboxylate anions. Now, non-saponifiable lipids means a lipid that does not undergo base hydrolysis or hydrolysis reactions in alkaline conditions. Or you can say non-saponifiable lipids do not react with water and base, like sodium hydroxide, potassium hydroxide. So that's saponifiable lipids and non-saponifiable. Let's talk about saponifiable lipids. Don't forget, this stuff is on test 4, not test 3 next week. Now, what really is a saponifiable lipid? Well, it's got another name, fats and oils. And fats and oils, I think you're familiar with. If you have bacon grease, that's the fat from a pig when you make the bacon and it's left in your pan after you fry up your bacon. Or oils, vegetable oil is an example, olive oil. Now, they're all, one way of calling them is triesters of glycerol, but most of you know them as triglycerides. And a number of years ago, when I went to a new doctor, I was looking for someone new, and there was a practice, or actually it's pretty big here in the Schaumburg and northwest suburbs, called NCH Group, Northwest Community Hospital Group. They're really good. And one that I went to was like 5 minutes from my house, such a deal. And unfortunately had to retire because of medical problems, but someone else, the practice I now go to is just as good as him. But Dr. Cantor, I had my first physical and he called me and said, I got to talk to you, you got to come in. And I came in, he said, one, you're overweight. Well, I've been that way my whole life, unfortunately, even though I'm trying to undo the damage of Passover. Matzah and matzo balls are not low calorie stuff. But anyways, he said, you got high blood pressure. We got to get you on medication to take that out. And your triglycerides are too high, meaning I'm eating stuff with too much fats and oils. And that's how I could tell her, and from my blood sample. And he was pretty straightforward. I don't know if it's because I'm an organic chemist or he's that way with everybody, but I've had a number of doctors who treat me that way, and dentists too, which I enjoy. And he said, let me show you something. He pulled up this report on the monitor in the examining room. And he said, do you see the abstract? You're in the percentile group that if you don't do something about your blood pressure and your triglycerides, you'll be dead in 5 years. That got my attention. And yes, I brought that down. My blood pressure is much better. I am going back with the pandemic and also Passover. Well, I haven't done bad as some people I know, but I need to take off weight. But that's triglycerides. That comes from eating fat stuff with fats and oils. Now, what is the structure of a triglyceride? Remember, I said no new reactions, no new really functional groups. You should know this. And this is a triglyceride, otherwise known as a fat or oil. All fats or oils have this structure. The only difference is what's our prime and our double prime. Now, one thing I should warn you about, synthetic organic chemists write their esters this way. Oil chemists, I'm not talking about petroleum oil, those are called petroleum chemists. Oil chemists, chemists who deal with fats and oils, write their esters this way. And these are both the same in terms of they're both an ester. And if we come over and look at here, by the way, I better tell you, better spill the beans. For a number of years, I worked for a company that worked with fats and oils. In fact, I worked for a company that bought their products, and we were having problems with making our high quality products because the starting materials we bought from this other company was causing problems. And I saw what the problem was. I went and worked with that company and said, here's how you improve your product. So I have less headaches to deal with, because my job at that company was the plant couldn't make the quality, I would get there. Tom, you got a question?
No, I don't. Sorry.
You don't have to be sorry. I'll just shut your mic off. I can do that. Didn't know Dr. White was that powerful. But anyways, because I solved their problem and helped them make a better product, which made my life easier, the company headquarters, they were just increasing in the United States, was in New Jersey. They bought a plant in Chicago by White Sox Park, Racine and 47th. I so impressed the president and other people there. They said, well, we're coming to Chicago. We know you don't like leaving. I live in the Chicagoland area. And we're looking for a new lab manager who will not only manage the quality control of the plant, but you'll start up a whole new research and development section in the United States. I said, well, I don't know. I'm happy where I am. I'm doing well. And they made me an offer I couldn't refuse. They doubled my salary. And I couldn't refuse that. Goodbye. I was making darn good salary at the other company, but now I was doing good. So anyways, Dr. White knows his fats and oils. And in Urbana of Champaign-Urbana is the headquarters for the Oil Chemist Society of America, or American Oil Chemist Society, that's the proper name, which I was a member of for a number of years. When I left that company, I'm not going to pay that extra money. So the company paid for it, so I dropped my membership. But they deal with fats and oils. And it's a multi-million dollar industry in the United States. So every fat and oil has this structure. And if we look at right here, we have ester number 1, carbon, oxygen, carbonyl, carbons, ester. We look right here, we have ester number 2, carbon, oxygen, R prime or R, like up here, carbonyl, R prime, and here we have ester number 3, carbon, oxygen, carbonyl, R group, in this case, R double prime. Every fat and oil has this structure. The only difference is what's R prime, and R double prime, and I'll be teaching that Not today probably, but later on. Now the question is, what's a fat and what's an oil? You should know this. Oh, get out of my way here. Now, a fat is a triglyceride that's a solid or semi-solid at room temperature. You don't have to know, but by definition, room temperature is 25 degrees Celsius. And what's a semi-solid? I think you all know what a solid is. I don't say you have to do this, but think about if you have a jar of mayonnaise and you stick your finger in there and go, oh, that's a semi-solid, as opposed to the top of this is solid. So a fat is a triglyceride, triester, that's a solid or semi-solid at room temperature. If you don't like mayonnaise, if you leave butter out, a stick of butter out for a while and it gets nice and mushy and you go like this with your finger, or you can use a knife if you don't want to use your finger, and sort of mushy, that's a semi-solid. And an oil is a triglyceride that's a liquid at room temperature. So you should know fat, triglyceride, that's a solid or semi-solid at room temperature. Oil, triglyceride, that's a liquid at room temperature. And that's why we call it olive oil, because that material, that's a triglyceride that comes from olives, it's a liquid at room temperature. Same thing with vegetable oil, though it's triglyceride that comes from various things like corn oil, and other seeds that are vegetables. Now, let's talk about the reaction of a fat or oil with an acid or base. I'm just going to do the acid, and we'll take it up on Monday after I do my problem set. Remember, Monday, we'll do the amines, amides, quaternary ammonium salts, and amine salts problem set, and also review. And after that, we'll have some time to get back to this. Now, see board, I better get to work. What happens when you react a fat or oil, a triglyceride, with acid? Let's find out. And if we look at this reaction, everybody see that on the whiteboard on your screen? Thank you. Here we have any fat or oil and acid and water. And this is a very important reaction. Why? And when I took notes, if I wrote this in the left margin, a couple stars, an IMP and an arrow, you better know this. Why is this important? Because this is how your stomach breaks down fats and oils you consume. Now, if we look at right here, Dr. White said no new reactions. Well, this isn't. And for test number 3, you should learn this, but I'll write it a little differently. If you take an ester, acid and water, what happens? You get back the alcohol plus the carboxylic acid, and I'm writing it now as a fats and oil chemist or an oil chemist would do, plus the carboxylic acid you would use to get that. Well, here, I'll call that R, and here I got an R. I should actually do this. I'll call that R, and this becomes my alcohol. And this part becomes this part. So I get an alcohol plus a carboxylic acid, but that's attached to something. Remember, you don't break carbon-carbon single bonds. So here's my second ester, and here's my R group, and my R and the carbonyls are double prime. So I'll have this alcohol plus now this carboxylic acid. And finally, the last ester, here's my R group right here. So I'll get this final alcohol. And then this part becomes my carboxylic acid. So when you react then fat or oil with acid and water, acid hydrolysis, you get this alcohol, and that's a triol, which we call glycerin. And we get these carboxylic acids. Now, it turns out organic chemists are lazy if you haven't figured that one out. Instead of calling these carboxylic acids from fats and oils, oh, that's too much to say, carboxylic acids from fats and oils, I'm going to just call them, let me write it better so I can read it. Fatty acids. And fatty acids are carboxylic acids that come from the acid hydrolysis of fats and oils, these. And glycerin is also made. That's the alcohol when you hydrolyze the three esters. And your body actually makes glycerin and carboxylic acids. And the company I told you about, the company I worked for, originally bought carboxylic acids and made them into things. And the company that stole me away, made me an offer I couldn't refuse, made glycerin and carboxylic acids, otherwise known as fatty acids, to the tune of about 100 million pounds a year of fatty acids and a similar amount of glycerin. And this is a reaction you should know, and we'll do examples later on this chapter. And if I look at the clock, I'm going to say, guess what? It's time for a lab. Now, since I can do this on Zoom, I can cheat. How's Dr. White cheating? Well, normally if we were at ECC for face-to-face Wednesday lecture and lab, we would have stopped at 1:50, take a 10-minute break. At 2 o'clock, we'd go to the lab. And I'd talk for 20 minutes. You go in the lab and spend time. And when you're done, you'd leave. And almost students on certain labs get out at least 10, 15 minutes early. Well, guess what? You're not going to be working with chemicals, so I can cheat. And I took an extra half hour. Don't tell anybody. All right, it's lab time. Let's have fun with our lab. Let me open it up. Let me close some stuff first. And today's lab deals with esters and carboxylate anions. And it's available for download either as a PDF. I did it yesterday afternoon. I think I uploaded it sometime yesterday, or as a Word document on D2L. Everybody see what's on the screen? Carboxylate, thank you. Now, esters are very important in nature. As I've said today, esters are responsible for the odors of many fruits and flowers, and they're also responsible, I don't have here, for the taste of many fruits and vegetables. They can be used to make polymers. The other thing I'll talk about today is carboxylate anions. Now, in part one, and Dr. White's sad, because I wish you were in the lab now. So much fun, because you're going to make esters, and you're going to find out if Dr. White was lying to you. And you're going to make them, then you're going to smell them, and you'll go, wow, I made that. And you did, but I'm going to pout for a while. Remember, how do you make an ester? Carboxylic acid plus an alcohol. Acid catalyst is a reaction where in the lab we use sulfuric acid as the H plus. H plus, this says any acid, and you need a strong acid for this, and you make an ester. And what you would be doing in the lab is mixing together in a test tube. Oh, that's an awful test tube. Don't look, don't look. Somebody looked, they're smiling. That's a better one. You'd put some of the carboxylic acid in the test tube. You put some of the alcohol in there. Then you'd put some drops of this in there. You'd have a beaker. This is a hot plate. This is a plug where you plug it into the wall. And this is water. You heat this to 50 degrees C, put the test tube inside, let it go for 10, 20 minutes. When you're done, have another beaker with ice in it. You pour the test tube in there and swirl it, take it out of the fume hood you've been working in, and properly smell it, which I show you how to do. And that's part one of this lab. And there are different parts. Glacial acetic means pure acetic. I guess I got the term glacial, now I'm guessing, because glacial acetic is pure colorless liquid. In chemical industry, if you worked in a part that measures colors of liquid, which I have, that would be APHA, maybe 5 or 10, which means it has almost no color at all completely. Now this one you do two parts. In one, you'd put in both test tubes, you'd put in glacial acetic acid. And you know what acetic acid is? Nobody calls it ethanoic acid. And then one of the test tubes, the alcohol, you'd add ethanol. The other one, you'd add 3-methyl-1-butanol, also known as isoamyl alcohol. It's a common name. You'd mix it and then add drop-wise about 10 drops or 1 milliliter of concentrated salt. 10 drops is 1 milliliter. And then heat it for 10 minutes. Then pour each test tube in a separate beaker and stir it and then smell it. And you would form an ester. Don't forget to draw the structure here. And turns out with ethanol, you'd make ethyl acetate, which is nail polish remover. Now this one really blows students' minds. With this alcohol, isoamyl alcohol and acetic acid, you form an ester, which is the ester you smell and taste in bananas. Now, since there's strong acid in there, we're not purifying it, can't taste it, but you can smell it. And what's amazing is the students go like this, I don't know what I'm smelling. And I come over and I say, hold it real far away. Now go like this. And they smell, and I say, can you think of some candy that's yellow? And they all say, oh, Laffy Taffy banana. How come I didn't? Now I can smell banana. How couldn't they smell banana was right underneath their nose? Because they made a pure beaker of ester. The amount of ester molecules hitting your nose is tremendous. And when you smell a banana, you're only just getting a few of them up there. So it overpowers your nose, and it takes a while for it to get used to that. Now, why do they say Laffy Taffy banana instead of a regular banana? Because there's a stronger amount of that ester in that candy. I guess you call it candy. It's not really a basic food item, but it's that product. And then I would go around the lab, when each student, I'd say, call me over because I like to smell it too, even though Dr. White hates to taste the bananas. You can have mine. But anyways, and after they smell it and everything, I ask them, do you now understand what they mean by artificial flavorings? You make the ester in a chemical plant. If you buy something with a banana taste to it, they're not taking bananas, crushing them and putting it in there. They're making that ester in a chemical plant by carboxylic acid, alcohol acid. They purify it so you don't get sick from the acid in there. All right. Now, in part 1B, you would add methanol to salicylic acid, and that ester, when you smell it, is strong minty, is mint, really, ester, and it smells like mint lifesavers. Now, in part C, you'll take acetic acid and react it with 1-octanol, and hold on, I need a student assist here. Tom, do you still have your orange handy? Hold on, let me unpin myself. Say something so you get on screen.
Yeah, I got 2 oranges here.
Ah, a pair of oranges. Say
I
it
think
again.
there's esters in it.
Smell it. Guess
Smells
what?
like esters.
That was the ester of acetic acid and 1-octanol. Thank you for your assist.
Welcome.
I appreciate it. Seriously. Thank you. And you would have smelled that and you go, wow, an orange. And students get all excited and have a good time. Now that's that first part of the lab. Let's go to the next part. And this one, we're going to talk about things that absorb things, such as diapers. How many of you have ever seen the commercial in the last number of years where they're selling these super absorbent diapers? Or, and this is organic chemistry, there's certain feminine hygiene products that use a certain time of the month that are super absorbent. They're the kind that are liners or other things. They've been selling thinner and thinner and thinner. How do they do that? Organic chemistry. And the molecule that absorbs the water, because in a diaper or feminine hygiene, what you're really trying to do mainly is absorb water, is polysodium acrylate. Now, what is this? Let's take a look at this. Everybody see my whiteboard? Thank you. Now, the molecule is a polymer. You know polymers now. And this is super absorbent polymer, abbreviated SAP. I actually consulted for a company that at one point made the main manufacturer of this compound till their patent ran out. And this is a carboxylate anion. And this hydrogen bond's real good. To water better than carboxylic acids. And here M is sodium, and here is the order of about 500,000 to a million. And this is what absorbs the water. So in this lab, you're going to take this molecule and put some water in there. And you're going to do this with 2 separate beakers. And in one of the beakers, you'll just put in water, a certain amount, I think 1/10 of a gram of the sodium polyacetate. Actually, that'd be acrylate. Yep, I've just caught a mistake. This should be acrylate. And the other one, you also put in the same amount of the acrylate. And then you put in about 5 milliliters, DI means deionized water, and you take a glass stirring rod and you observe. And if we look here, they both become a gel. Now, next, I asked you to put in some phenolphthalein and add enough dilute acid until the color goes from pink to clear. And that's what this phenolphthalein will show you. It's an indicator, pH indicator. And what you'll do, and sometimes we even have pH paper we use too. That's in your drawer. And what happens is when you add the acid, it becomes a liquid. And then I ask you to that same sample, beaker 2, now add base again. And it becomes a gel. Well, what happened? Well, when you add acid to the SAP, the HCl, this is a conjugate base, this is an acid. And you get this. And this does not hydrogen bond as well as this. And then when you add sodium hydroxide, and this is in water, but anyway, sodium hydroxide solution, here's a carboxylic acid, a base, and you get back this carboxylate anion. By the way, this whole thing is inside the bracket. And now this will hydrogen bond better. And that explains why you see that results. And if you notice, I have a bunch of questions here for you to answer. And this is due next Wednesday. And with that, I'm done. You get to get out early today. Yay, Dr. White. Thank you. You're welcome. With that, first of all, let me remind you, there's a lab due today. Yes, Cynthia, you give me a great thank you. But anyways, I have my office hours tonight. If you have any questions on anything you need help with, stop by. I'll be there, and you're always welcome. Don't forget the lab we did last week is due today. And I forgot to tell you, this morning, I uploaded your last week's labs scores. And Tom, the two we were talking about, I uploaded those scores too in D2L. And with that, I'm going to say, don't forget to study. A week from today is test number 3. On Monday, I'll go through the amides, amine salts, and quaternary ammonium salt problem set. I'll do my world famous review for test number 3. Study this weekend, and I'll see you on Monday. Gehen gesund, be healthy. Gehen gesund. Goodbye.